Okay everyone, so here's my filament review that I promised. I'm going to review 4 different filaments here. The first of which would be the one I printed the XZ axis supports or rails, whatever you call these, out of. That was WYZ black PLA filament. Didn't really have any problems with that filament. Printed really nice on the temperatures they said. I think I printed like 5 or 10 degrees Celsius above what they recommended. But other than that, great filament. Didn't have any issues with it. Second up would be this filament here. This is what's called solid yellow PLA filament. This one is from filaments.ca, which is a Canadian filament supplier. The color of the filament you can kind of see on this part over here. Really nice color, it's pretty bright, stands out. And the finish of the parts it printed was actually really good. The only issue I seemed to have with it was about halfway through the roll, when I would shut the printer off and come back the next day or whenever to print something, I would actually find that the filament going into the extruder body right here had cracked off on its own while the printer was setting there. So I would have to take the stem that was stuck down in here, I'd have to heat up the extruder, take it out, and reload the filament back into the hot end. And this kept happening all through the second half of the roll. The first half of the roll I didn't have any issues. I don't think it was a moisture problem with the plastic itself, because I live in a pretty dry area, a pretty dry climate. So there's not really that much humidity or moisture. But it would only crack within a couple inches here of the extruder body, which is really weird. All I could figure is maybe it was the residual heat from the extruder body as it cooled affecting the plastic. But it got worse, and as I got near the end of the roll, every time I would stop printing to come back to it, didn't matter if it was 6 hours, 12 hours, it would be broken, or as soon as it would move out to print, the filament would snap off and then I'd have to stop the print. So I didn't like that about it. I don't know if there was something wrong with that batch of plastic or what was going on, but that was the only thing I found that I didn't like from that filament. So that was 1.75 solid yellow PLA filament from filaments.ca. Pretty nice filament. I printed the supports up here for the spool holder in that as well. Pretty nice stuff. The only thing I noticed about that filament versus the WYZ black I started using originally with the printer was it seemed to shrink a little bit more. I don't know if it was just me or a setting I had, but it seemed like it shrank a little bit more as it cooled than the black WYZ had. So anyway, third up is the PLA filament I'm using right now. Let me grab it here. That would be this roll here. It is basically just gray, 1.75 millimeter PLA filament. This is from FoxSmart. I was reading a lot of reviews and people said the FoxSmart PLA was really good stuff, so I decided to give it a try because I didn't like the stuff from Canada due to the breaking problems. And I have to say, the FoxSmart PLA is awesome stuff. Let me grab something here I printed with it. Here we go. Hopefully this is in focus here. Just a really beautiful finish quality to it. Obviously my printer has been modified so that there's no waves or lines, but even beyond that, just the print finish of the actual filament itself is extremely smooth and consistent. It's a really beautiful finished part or result from that filament. It seems to shrink less than the yellow stuff that I mentioned earlier. And I would say it might even shrink a little bit less than the black, but I don't have any scientific stuff to back it up. It just seems that way. So really nice stuff. Would highly recommend the FoxSmart PLA, especially for 20 bucks a roll. I buy it on eBay from a seller on there that sells it. I don't know if it's actually FoxSmart. I forget who the seller is, but if you order some of the FoxSmart PLA for 20 bucks a roll, you can't lose. It's amazing plastic. The fourth plastic is the one I promised to review on the last time, which was this. It's actually loaded in the machine right now, but it's up out of the view here. It's called, let me get this where people can read it, Form Futura. It's a carbon fiber reinforced filament. It doesn't specify what the base plastic is, whether it's PLA, ABS, or something totally different. It's just some kind of carbon fiber reinforced filament. But it's actually pretty strong. I'm going to go ahead and pull the bed out here. I just finished printing a wrench head here, a socket wrench head. And I want to see if I can actually get this head working. So I'll try and load that onto the end of this video here if I can get this disassembled and actually functioning. I haven't been able to print any socket wrench or crescent wrench that actually functions. The moving parts end up fused. I do have some here. I'm going to bring one over. This is one in the gray PLA. Beautiful quality. Prints amazing, and I did get the screw here to turn, and I got this part to move a little bit, but it doesn't actually move enough to slide up and down, so still having issues. It has to do with the spacing, the infill that prints in here, and just so many parts that are close. When they start touching each other, when the plastic is still hot, they don't want to slide later on, even when they cool down, so I might have to put a little oil or grease in there to get it working, but I don't want to make a mess before I get everything cut loose. So yeah, that's pretty much it. The only other thing I can tag on here, before I go to the next filament, the carbon fiber filament, I printed one of the other videos. I showed a preview of this filament in a turbine blade, which had really thin fins, and I said it wasn't that much stronger than PLA. To be fair, it wasn't that much stronger. It is very light though, extremely light. And the one thing I notice about this stuff is when you print something like a bolt or a nut or a wrench that actually has some dimension to it, some depth where it's going to have some infill, this stuff is nigh indestructible. You almost can't break it with a wrench or a pair of pliers in each hand. This stuff is pretty crazy strong, so if you're printing something with some actual form to it, like you could probably even print a nut and thread it onto a bolt. I doubt you'd be able to break the threads off if you had it printed with the right temperature settings. But yeah, the last filament I'm going to review, let me see if I can grab it here, is this one, which is just gray ABS filament from the same Canadian company, filaments.ca. And the only thing I wanted to mention was a lot of people asked me about settings. Actually, one or two people asked in my last video about settings for printing ABS. And what I found so far is ABS is a pain in the ass to print compared to PLA. PLA is extremely easy. I would recommend get your printer working perfectly the way you like it with whatever mods you want, whether it's mine or otherwise with PLA. And then once you have it all dialed in, then go if you want to mess around with the ABS, but it's really a pain in the ass. Number one rule is you can't have any kind of airflow hitting your ABS part as it's printing, or it will warp extremely bad. The ABS shrinks really bad when air hits it. So this blower assembly, if this blows on your ABS as it's extruding, number one, it won't stick. And number two, even if it does stick to the previous layer of ABS, it won't stick very well, and it's going to shrink really bad. I was printing a little model or something on an acrylic sheet. I took the glass off here and put on a piece of acrylic, which is the only thing I found that the ABS would actually stick to. And it stuck to the ABS, but the problem is I only had two sides clipped, not all four sides. And I had the air here running because I didn't realize ABS was so sensitive to airflow. And so halfway through the print, it was printing okay, but it was shrinking so much that it was warping the piece of ABS up and off this aluminum bed. Like literally it picked it a good 1.5 inches, 2 inches up on the side. So we're talking major warpage. I had to actually stop it because the part was going to hit the extruder body and start mangling stuff up. So I had to stop it and take it off. But I tried printing ABS on glass. I tried printing it on glass with hairspray, which people recommended. It kind of stuck to the hairspray at 80 or 90 Celsius bed temperature, but not that well. I couldn't get it to stick to it repeatably. Everyone says the Kapton tape works well, but I'm not going to pay 50 bucks for a roll of tape just so I can print ABS filament. Why would I use ABS when I could use PLA? So that's just my take on it. For the money, I would never consider buying that type of a tape just to print a filament that's so similar to other plastics out there, especially considering all the problems you can have with it, including airflow. I mean, I'm talking if you're in the middle of a print and you walk fast past your printer and cause a little whoosh of air, you could have that layer delaminate later because of the airflow. So very picky stuff. But other than that, that's pretty much it. Hope you guys have a nice day. Check back for more updates. I'm going to be uploading a later video later that goes over print settings, specifically layers, infills, and all that stuff. A lot of the stuff I learned when I was printing. I've been printing molds and stuff recently. I'm going to go over a lot of details and things that affect your actual print quality of your final objects, the shape, their tolerances, stuff like that. So one thing I'll show you real quick as a teaser are these gaskets I've been making. This is a silicone gasket. Flip it up on the edge here. And if you watch my previous video for the mods, it is the motor gasket for the Z-axis motors right here and right here. And of course this is much softer since it's silicone. It's much softer than the available print materials at the moment that you can print in, flexible. So this is I think it's a hardness of 40. Whereas the filament I printed it out of, that clear stuff, I think was an 80 or a 90. I want to say 80. I think the shore hardness of that was 80A and this is 40A. This is more what you really need for it to function, even though those work. This stuff is nice and squishy. You can squish it between your fingers. You can stretch it. So if I was to put these in the motor, which I'm going to, I haven't yet, it will just allow you to adjust the motor a lot easier. In other words, instead of clamping these bolts down until they start compressing, I had to actually compress the screws, even with washers on them, down into the vinyl print material to get the motor to aim straight. This would compress a lot easier and it'd be much easier to aim the motor where you wanted to with less adjustments. So, and the file for printing the mold for this is on Shapeways as well already. Sorry, not Shapeways, it's on Thingiverse as well. With the file that you can print for the gasket itself, I also uploaded the molding file. So if you want to print the mold out and cast these out of silicone, this silicone in particular is from Smooth-On. I think it's Smooth-Sil 940. It's a food-safe silicone. I just got it because I figured why not have food-safe silicone, especially since I'm probably not going to use it all for gaskets. But I'm thinking of selling these online. I'll let you guys know if I decide to start selling them in sets, because they'd be really nice to put on the motor mounts on this Prusa and others to allow adjustment of the motor direction. So anyway, that's it.